Hello. Yeah, today just got to finish make it a smaller generator. This is an E-generator. It's gonna run by battery, and the battery can be charged by from the grid or solar panel, or from the generator itself to charge the battery. So to make it more efficient and the battery lasts longer, we like to have the battery in between, in the low 40% and up to 80%. Within that 40 to 80%, you don't need to charge it until it get below the 40, and then you're gonna stop at 80%. So like I said again, it's a three-way to charge this battery: the grid, solar panel, or from the generator itself. Okay, this generator is gonna run AC power only. Okay, and with that AC power, it's gonna come out three-phase, as you can see. And this is a rectifier, so you can use dual AC or DC power, or both at the same time. But you're gonna need a converter to appropriate frequency, voltage, and for the DC side, you need to reduce the voltage to the right, appliance that you need to use. So basically, the battery power the inverter, and this inverter would power the generator. And you're gonna see right now is the input power, and then the DC output, and then AC output. Okay, so let's start and see. Okay, first of all, I gotta turn off the inverter. You can see, okay, get up to there, and it's 41 point, about 41 volt. Okay, and then you can see we're gonna turn on the other meter. We're gonna power the generator. And this is the controller. I don't know if you can see that. Well, right now it's running 50 RPM. And you can see right at 40 RPM, you can see it's running, consuming 20 watts. The DC side is 28 volt on the orange meter. The red meter is 20 volt AC. So we're gonna increase the speed. Okay, and you can see it's spinning much faster. Alright, and you're looking at the red meter is 206, close to 260 volt AC each phase. The DC side is 358 volt. You see it, and it right now is consuming 197, so let's say 200 watt. Okay, and now let's check the DC output for the amperage. Right now you can see 143 amps, okay, for the DC. and we're gonna test it, the AC amperage later. And right now it's totally run on the battery. Yep. But right now this setup, we don't have the inverter yet, so which we can loop to battery charge, charging the battery from the solar or the generator. It's the only way we can do right now is charge it from the grid. So here I'm gonna attempt to do that right now. This is 110 volt. Okay, soon we plug it in, you can see this battery is charging right now. You can see the flashing green light. Okay, it's telling it's charging. And some of them it's still full, so it's not charging. This one charging, this one full. See, 4 bar, so it's not charging right now. Okay, so what it means is it can power and recharge at the same time. So if you can keep up, maintain the same voltage all the time, either with solar or the generator, then you can have this generator power for a long time. And again, the amperage on the AC on the input is 2.7 amp. The voltage 127 volt, and it's coming out to 194 watts. So look at the amperage here, 143 amp. Okay, you have a lot more. Okay, and next step we're gonna do is increase the power, the speed. You can see everything going up. The amperage on the DC side, you're looking at 260 something, 70 amp. Let's see the voltage. Close to 680 volt. AC size about 500 volt, and we later gonna measure the amperage. It's gonna be 40 amp. I hope you can see it clear. What to do is 3, so you can see both 3 at the same time. Since the input's only 400 watts, right? To charge this battery, all you need is one solar panel that can handle 400 watts that you can buy right now, and just plug it in. And right now you got the sun, so you should have at least 5 hours. The generator can have a full output, and you don't have to pay for any electricity. And the RPM right now we're running, I don't know if you can see it, but it's 1150 RPM. If you can't see it, we have to clean it. And you can see the whole operation off grid. And the production model is going to be smaller, so you can use this to charge your electric cars on the move or stationary. So this technology you can apply to anything, even cellular phone. You can downsize to small as a battery and put it into your cellular phone. You don't have to charge it for a long time. Or you can add to any appliance, any machinery. It would run on its own. And other household appliance, you can do the same thing. So in the future, your house, you don't need to have a electrical wire internally, because everything will power itself and it runs its own, either at home or anywhere else. Plus, you can use this technology embedded in this battery. So this battery will last for a long time without charging, because it has internal charging system. So that's another idea that you can use. Okay, so right now I'm gonna shut off the machine. I'm gonna measure the amperage on the AC side. Okay, it switched to the AC, the amperage. Okay, now it's going to around close to 600 RPM. And you can see is right now it's about 23 amp. The AC now, right now is 253 volt. You understand? And its input less than 200 watts. Okay, so if you take 23 amp multiplied by 250 volt, you get about, I don't know, roughly 15,000 watts, which is a lot more than the input power, as you can see. Okay, remember, you can see right now again, only 2.3 amp versus 22 amps is already, 9 times more on the amp, and voltage is 120 watts, 120 volt, 126 versus 500 volt, which is 3-4 times more. So substantially more on the output than input. Okay, let's increase to the twice the speed, maybe 1100 RPM, and you can see the amperage moving up, 39.4 amp. The consuming power to run the generator is a little bit less than 400 watts. And let's check the AC voltage. You're looking at 500 volt closely. So very efficient generator. Okay, and if you look at the inverter, it's maintained 41.1 volt. See, it's always stable. So as long as you keep on the same power like this, you will never run out, unless the machine burned out, whatever, mechanically or electronically. But as long as you can keep the heat in the same level, that thing will last for a long time. Okay, that's it. So the next final production, like I said, it will be half of this size. Thank you.